PL/SQL Basics. Although the SQL Fundamentals 1 exam objectives don't reference PL/SQL specifically, I've decided to give you this nugget as added value to the course. In good conscience, I can't very well teach this material and have you call yourself proficient with Oracle SQL without having at least a fundamental understanding of PL/SQL. It's just that important to Oracle database development. To that end, we'll begin this nugget by defining what PL/SQL is, why it's cool, and the basic use cases for this programming language. Next, we'll understand what a PL/SQL block is, which, as you probably can imagine, represents the fundamental building block, just couldn't resist, of the language. We're going to learn that there are two types of blocks supported in PL/SQL, the anonymous block and the named block. Named blocks, we'll learn, are also referred to as stored procedures. We can also do functions, packages, and other really cool object types. By the end of this nugget, as I said, you'll know the fundamental vocabulary of PL/SQL. Of course, a subject this broad, there's so much that's going to be by definition beyond our scope, but I'll at least give you pointers for further learning. Let's get started. What is PL/SQL? Well, PL/SQL, if we break out the acronym, refers to procedural SQL. It's one of the three programming languages supported by Oracle Database 11g, the other two being SQL and Java. Leave aside for a moment the common argument that many people do not consider SQL to be a programming language. The bottom line is, if you're going to be proficient as at least an Oracle 11g database developer, you'll need to be proficient, of course, with SQL, but also with PL/SQL, and then for more computationally rich functions, you'll want to turn to Java. Now, what does procedural mean? We know that SQL itself is a data access language. Pretty clear we can create, alter, and drop objects, and then we can perform operations on those already created objects. Things like executing code, which we'll cover in this nugget actually, selecting, inserting, updating, deleting, and so forth. Well, again, keeping in mind our limited scope here, procedural programming is an old-fashioned type of programming, also called imperative programming, and the notion here is that we're breaking our code into modular chunks, or routines, subroutines, a lot of vocabulary steps on each other here. But the notion is you're storing these reusable blocks of code in Oracle Database, and you can refer to those units of code, or shall we say those procedures, as you need to suit your business needs. Again, code reuse is crucial here with PL/SQL because it does take a while in some cases to figure out what you want PL/SQL to do, and then you create the function, you create the procedure. You're going to want to store that in the database for later reuse. Some specific distinctions between PL/SQL as a procedural programming language and SQL, which, as we've already said, is more or less just a data access language, include the following features. PL/SQL enables us to create dependencies between different commands in a single code block, and we can also pass parameters from one procedure to another. Now, if you don't have a background in programming, that probably isn't all that impressive, but we have to remember that SQL doesn't support these things. In other words, you may or may not have heard the old expression, you can't get there from here. You're going to definitely run up against a brick wall as you test the limits of SQL in your business logic. Yes, we have some rudimentary support for variables and parameters with SQL, but you have to remember that that statement terminator, or that semicolon, represents the end of the road for that particular SQL statement. We can't take parameters out of one SQL statement and feed them into another. We have all sorts of flexibility in that regard with PL/SQL. You can even pass parameters not only within a single code block, but also between code blocks that exist in different, potentially even different databases. We also have in PL/SQL the concept of variable scope. We now know what a variable is. I describe it as a data bucket or a data placeholder. Scope means we can create public or private variables and determine their visibility across those PL/SQL code modules. That's a common feature of any contemporary programming language. Other features of just about any programming language or even scripting language worth its salt include things like conditional logic, where we're using keywords like case or if then else to look at specific situations and then have the code fork depending upon the evaluation of an expression. Loops allow us to run statements or run code iteratively through a set of values. It could be a set of rows in a table until you reach a certain threshold and then the loop stops. Exceptions are very popular, very handy to have with PLSQL because as you run these different conditions and these loops with your code, you always need to provide or should provide some kind of escape hatch such that if something goes wrong in that condition or loop, you have some handler in PLSQL code to trap that exception. Again, this is common vocabulary for those of you who have done programming. If not, don't get too bogged down in the terms. Just gently approach them and then let your interests carry you from there. So in conclusion, the take-home message from this whiteboard is that PLSQL represents an Oracle proprietary extension to the structured query language that gives us procedural programming logic and enables us to take our Oracle database access to the next level. Speaking of which, you'll note in my footnote here that the best practice recommendation is to use PLSQL only for data access tasks. In other words, PLSQL, when you stack it next to current programming languages like Java or C++, PLSQL is going to be left in the dust. Those programming languages are optimized for number crunching. PLSQL is not. Remember, we always want to choose the correct tool for the job. And as I said earlier, Java is the official supported programming language in Oracle. So if you do pursue database development as a career, you'll absolutely want to study Java. One point I almost forgot to mention is that Oracle 11g, more than any previous version of Oracle Database, embraces the principles and design patterns of object-oriented programming. Now, although procedural programming, I would consider it kind of a precursor to object-oriented programming, they are different paradigms. You have the ability to work more in a procedural paradigm, or if you want to move toward classic object orientation. It's up to you as a developer. Anonymous blocks. When we sit down to start analyzing PLSQL code, you'll come across a fundamental term that's crucial that we understand, and that is the concept of the PLSQL block. And very simply stated, a PLSQL block is PLSQL code that is contained or encapsulated between two keywords, begin and end. It's as simple as that. As long as you have a begin and an end, and at least one line of PLSQL code in the middle, you have a PLSQL block. Now you can go on and stretch the begin and the end, as I'll show you in just a moment, but this is the formal definition. Next step is understanding what anonymous blocks are. At first blush, this sounds all mysterious and really esoteric, but it's not. All an anonymous block is, friends, is an unnamed PLSQL block that's not stored in the data dictionary. As we're going to learn, when you create PLSQL objects, named objects, they're stored in the data dictionary. Anonymous blocks are akin to running ad hoc queries against the database. We'll remember that ad hoc is Latin for this purpose, and it refers to not storing any of your work, but simply interactively running code against Oracle database. And then after the code's gone, the code's gone. Nothing is stored. PLSQL code that is stored in the database is compiled at runtime into machine language for faster reuse and rerunning. Anonymous blocks aren't like that. They're compiled all right, but then the compiled code is immediately destroyed after the code finishes running. Therefore, anonymous blocks are typically, no rules here necessarily, but typically not best practice for Oracle database development. Remember that the whole principle of procedural and even object-oriented programming is code reuse. We want to not have to reinvent the wheel, if you'll pardon the shop-worn cliche, and having to construct our code blocks over and over and over again. We want to be able to store once, run many, if that makes sense. Down at the bottom here, I've given you a sample anonymous block from the Wikipedia page on PLSQL. It's a good article, by the way. Definitely check it out. And it's a fairly academic example. It's not all that practical, but it shows you the basic elements of any PLSQL block. Now remember, you have the begin and the end where the meat of the procedure exists, and that is the case here with this example. In most cases though, when you compose PLSQL blocks, you're going to be declaring and initializing variables. And you do the variable declaration using the declare keyword, and that actually shows up before we begin the procedure. And hopefully that makes sense to you intuitively, because we very well can't start working with variables that haven't been actualized in memory. So if we're going to do variables, this is officially an optional clause, we will name those variables and then provide a data type for them. Simple as that, just like you would declare a data type for a column in an Oracle table. So we're declaring number 1 is our first variable that uses the number data type, 2 characters long. The number 2 data type is actually inheriting the value of number 1, and the percent type is just a PLSQL shorthand that carries over the data type of the referenced variable. Now, when you assign the value to a variable, you use not equals, which is traditional with programming language, but you use colon equals. It's a little bit weird on the eyes, at least it is with me. So on the second line of our code, we're defining number 2 as 17 as a default value. And then we're declaring 2 text variables that we're actually not using in the body of the block here. One called text1 that uses varchar2, 12 characters in length, and we're initializing the variable with the static string hello world. And finally, the text2 variable, we're creating that as a date data type, and we're just invoking the system function sysdate to populate that variable with today's date and time. Now in this simple example, we are packing the number 1 variable with the contents of the street number column in the address table. We're doing what's called a select into. So we're filling the number 1 variable bucket with whatever is listed for street number in our address table where the name is INU. So at the end of this procedure, we're going to have a variable that contains whatever street number is associated with the name INU. Again, kind of an academic example, but I hope you followed the logic just in general terms. The generic term stored procedures or stored routines is a little bit fuzzy depending upon which database platform you're talking about, and in my experience it's a little bit fuzzy even in the Oracle literature. Essentially, a stored routine or a stored procedure refers to named PLSQL code blocks that are stored in the database, in the data dictionary. Now as you see here, there are 4 types of stored routines or stored procedures, and one of them is confusedly called a procedure. You'll often be asked, this is possibly an exam alert question if you go on to certify yourself in Oracle database development. The question is, what is the chief distinction between a procedure and a function in PLSQL? As you notice, both of them perform some kind of work that you've defined as a database developer. And then you see I've let the cat out of the bag by giving you the answer. Procedures cannot be used in SQL statements. They are called specifically with the execute SQL+ command, whereas functions can be used in SQL statements, and they also give you great control over a return value. A stored procedure itself, a procedure, doesn't necessarily return a value out of the procedure back to the calling user or calling schema. The function always does. In fact, you have full control over arguments that go into the function as well as formatting the return value or values that come out of that function. So there's the issue of the return value that distinguishes the procedure and the function, but there's also, and this is really the main point as far as I'm concerned, functions are just so much more flexible. Procedures are compiled code blocks that we can execute, and yes, you can nest procedures. That is, you can write a procedure that calls another procedure in its running and then comes back to the first procedure. That's definitely doable, but we still don't have the flexibility that we do with functions. We've worked with functions, at least Oracle system-defined functions, thus far in the course, so you've gotten a taste of that. We can call functions in our select statement. We can oftentimes call functions in our create statement, as well as any DML statement, insert, update, select, delete. All of those support the function. So functions are extremely flexible objects. Next we have the trigger. When you think of a trigger, the definition should follow from that name really. A trigger in Oracle Database 11g is an event-driven procedure. It's a PLSQL block at base, but it has a fundamentally different purpose than a procedure or a function. A trigger fires, and yes, that is indeed the correct nomenclature, before, after, or instead of a particular action. So you can use a trigger to, and this is a common example, a real-world example, to write changes to archive tables. There are some shops that, due to service level agreements or maybe federal mandates, have to track every DML or even DDL statements that are issued against the database. And you might have situations such that any deletes, the raw data, the data that was deleted, has to be archived, such that you could have a trigger sitting on a table watching for the issuance of the delete statement. Of course, there's the whole issue of security. In order to successfully do a delete on a table, a user would have to be given that permission. We'll be discussing permissions and security in Oracle later in this course. But assuming Joe or Jane user comes over and runs a delete against several rows in a source table, that trigger can fire before, after, or instead of that delete. So you can prevent the delete from happening, or you could allow it to happen, and then the code of the trigger takes action. And what often happens in these kinds of businesses that need to track every change in the database is that the delete will be allowed to proceed in the source table, but all of those rows that were deleted will be stored in another table, perhaps on another server, in an archive table. You see what I mean? So triggers are really useful for many reasons. One, for data integrity purposes, to make sure that data is coming in and out of tables in a correct fashion, in a consistent fashion. Triggers are also used for security, for prevention of certain commands against table to, again, ensure data integrity. And they're also used for auditing and compliance purposes. Really nice code modules, triggers are. Finally, we have the notion of the PL/SQL package. And the package is a linked code module. It's a stored object that contains within its body one or more related stored procedures, functions, or triggers. You see what I mean? So you've actually bundled together related code objects under a single name. So you can run routines within that package by providing the package name, dot, and then the name of the function or procedure. More on that in a future whiteboard. Bottom line is, packages can be especially useful for code modularity. You might develop a package in your development environment and then just transfer the whole package to your production server, just in one fell swoop, instead of having to micromanage all sorts of different specific granular procedures and functions. You can put them all in a single package and work with all of those objects as an atomic unit. That also works well from a security standpoint because we can grant execute permissions to users once on the package instead of having to do it separately per procedure. Another point that goes beyond our scope, but it bears mentioning just briefly, is that Oracle does in fact have a utility called wrap that performs a function called obfuscating your PL/SQL source code. Now, what does that mean? That's a $5 word, isn't it? To obfuscate, or obfuscate, if I can pronounce it, means essentially to encrypt or to scramble your source code. Your developers may be working long and hard on innovative PL/SQL code modules, especially if you're going to be selling an Oracle application to your customers. You, generally speaking, don't want those customers to reverse engineer your code modules to look at the source code. So obfuscating using the wrap utility, and there's third-party solutions as well, enable you to secure those code modules such that crafty users, potentially competitors or malicious users, can't see the source. Another reason why you might want to obfuscate your PL/SQL is that some network-oriented procedures might require you to put passwords in that code in plain text. And again, we want to do everything we can to hide or scramble that so that those passwords don't fall into somebody's hands that we don't want them to. We're going to be doing a demo in just a moment, but before we do, a little bit more on the basic syntax of PL/SQL objects. This sample code comes to us from the psoug.org website, and this function will determine if a given number is even. And just the guts of what's going on here, let me just tell you in advance, is using the mod function, which calculates a remainder. And the bottom line is, if any number is divisible by 2 and comes up with no remainder, then it's even. That's what's going on mathematically. Now, what we have here is the DDL statement, create or replace function. So we're creating a stored named function in the data dictionary. The name of the function is, in this example, is even, and we then specify our argument. It's going to be a variable called num underscore in that uses the number data type. Remember I mentioned that Oracle functions allow you to very granularly define your return values. The return value is going to come back as the Boolean data type, so basically true false. Between our begin and end block we have, as I said, the guts of the function. It's going to take whatever number is passed into the function, let's just say 8 as an example, and it's going to run a division dropping the remainder. 8 divided by 2 equals 4, remainder 0. So this if statement, conditional logic now, is going to return true, isn't it? Because 8 is indeed an even number. Now if we were to run this function passing in 5 as its argument, 5 divided by 2 is 2.5. The mod or remainder is not going to be 0. So in this example, it's a simple if-else clause. Either the number evaluates to true based on this if block, or any other case in the exception block, we're returning false. Bottom line. And then we're passing out of the function the value. Our final point before doing the demo is how to call stored code once it's in the database. Now here we come up against some potentially snarly advanced topics that our scope limits us here to just the briefest of mentions. And one is, when you develop your stored code, remember that it's going to fall within a schema. So we have, let's say, the employees table is formally referred to as hr.employees. And if I create a function called emp, then that function is going to look like this, isn't it? So if a user who's not in the HR schema tries to call emp without the HR prefix, there could be problems, you see. So that's actually a guiding principle, not only for those who are calling stored code, but when you're writing stored code and you're referencing database objects between your begin and end block, you have to think of who is the calling schema and will Oracle be able to successfully perform name resolution to locate that object. So keep that in mind, number one. Now, as we said earlier, functions have much greater flexibility in being called than procedures do. As we know, we can select functions even against the dual table, as we showed in an earlier nugget. Inserts, updates can all involve system or user-defined functions. Variable assignments are colon equals, as we know. And this example here shows us one of the ways in which we can run procedures. This one shows the example of a function called myfunct that exists within a PLSQL package called pkg1_corp. Now, when you're doing this, that is to say, when you're calling a function or a procedure from a package, the name resolution again comes to the forefront. You may have another package called pkg2.corp that has a function called myfunct. Do you see what I mean? Therefore, name resolution and prepending object names is really important. So you've got the name of the package, dot, and then the name of the function or procedure that you're calling. You might even have the schema before the package name, depending upon how complex your work is. Finally, with stored procedures proper, as I mentioned earlier, we have the execute SQL plus statement. This can be shortened to exec, and we have to recall that the user will not be able to run any stored code unless they have appropriate permission to do so. In this demonstration, we'll have a look at PLSQL. As you can see from the title bar and the Query Builder Sheet tab in SQL Developer, I'm logged into Oracle Database as sys, and I'm going to start by showing you an example of an anonymous block. Starting on line 4 here, you see I'm using a set command to set an environment variable, set server output on. You'll often see this as you browse the web to look at PLSQL examples. This is a required statement that needs to come before your declaration, before your begin block, when you're using DBMS_output. The DBMS_ packages are Oracle system packages. There's a whole bunch of them, and output has a function in there called putLine that will echo text to the screen, and that's the last thing that's going on in this particular anonymous block. So again, if if you're going to use DBMS output, you'll need to set server output on so that those messages are echoed back to the user. Now, it looks like this anonymous block is going to calculate the area of a circle. You might know that the mathematical formula for computing the area of a circle is pi r squared. So here we have pi times, now we're invoking the system function power, and then v underscore rad, of course, is going to represent the radius of the circle. And because we're declaring that as a variable, we can expect that we'll be prompted for this parameter as soon as we start. In fact, that bears explicit notation, vrad number, and then we're assigning that to what will be prompted. Remember, we used these substitution variables earlier in the course. Varea is going to be the result, and that also is going to be of the number type. Then we redefine varea as pi r squared, passing in vrad. Final step of this basic anonymous block is where we put the line out there to standard out the area of the circle is, and then we use our concatenation operator and then specify varea. Pretty basic stuff here. Let me select this block and run the statement. It asks us for a value. I'm going to put in 100 to be s underscore rad, substitution. And then it tells us at the bottom of the output the area of the circle is, and then it gives us the value. So this is an anonymous block. It's not being stored in the data dictionary. No other user is going to have access to it. It's existent right now only within this session. If I wanted to, and I guess I'll do this now, I'll copy this block to my clipboard, open up an SQL file. I'll call it anonblock.sql, and I'll store it in my home folder, and we'll paste the code in there. What this will allow us to do is run that anonymous block as a script if we so wish. So let me fire up a terminal prompt here. Log into Oracle Database as sysdba. Use the host command to make sure we are in the proper directory. There's our anonblock.sql. You remember how to run SQL scripts, right? We use @anonblock.sql. And in order to run the script, I should have put this character in the script file, but it's actually a good educational moment. If you don't have the / in your script file to actually kick off the code, then you can do that manually by using / in SQL+. And there we go. There's our area of the circle. So anonymous blocks are all well and good until somebody puts an eye out, right? They're not being stored in the database, so their flexibility is a little suspect, it seems to me. If you want more comprehensive information on the built-in Oracle packages, I've shown you this ss64.com site before. This is ss64.com/ORAP, and it's an alphabetized list of Oracle supplied packages. It's kind of old. Oracle 9.2 is the version on which this list exists. You could do a Google search for Oracle Supplied Packages 11G to get a more current one, but this SS64 has a lot of really useful Oracle data. You'll notice that I clicked the Oracle button and it's now taking me to an A to Z index of Oracle SQL commands. And notice that all these commands are hyperlinked. Really useful stuff. Anyway, back to our regularly scheduled programming. Next, let's take a look at creating a stored routine. In this example, starting on line 18, we're creating a new function. Now, let's take a look at it line by line. You'll notice that the create statement says create or replace function. You want to be careful with or replace. You use this if you want to edit a function. That is to say, if we want to overwrite a function that may already exist in the data dictionary called getBal, then that's what this would do. And Oracle doesn't prompt you either. It just goes ahead and overwrites it. But you'll see that this is the traditional syntax for creating a function. Create or replace function. The name of this function is getBal, and just to tell you what this is going to do in advance, this is going to return to us the order total or the account balance given a particular account number in an orders table. Here, this example pulls not from the HR schema, but from the OE or order entry schema. This is another of the built-in sample schemas that Oracle gives us for our use. So you see that after the name of the function, we can specify one or more input parameters and even specify output if we want to. Here we're accepting one input argument. It's going to be it's input. Number is the data type, and it's called account number. So we'll need to have an account number in our mind before we run the getBal function, which should make sense. Remember, I mentioned that functions differ from procedures in not only their flexibility, but also in how we customize return values. We're returning that account number as a number data type. Now you might be wondering, well, what about our variables? Where do we declare declare those. Functions are a little bit different syntactically than procedures. Notice that we specify our variables after the keyword is with functions. Now, you don't need to know all this detail for your SQL Fundamentals exam. Certainly once you get into the Oracle Development Certification stuff, it becomes more important there. Just check out the general flow and beauty of this thing. That's all I'm asking you to do right now. So account balance is our defined variable, and it's going to be a number with precision and scale of 11 and 2. The meat and potatoes of this function, between the begin and the end block, of course, is going to do a select into. It's going to go into the OE orders table, and in particular, the order total column. Notice this fully qualified name. Remember what I said a little bit earlier in this nugget, that we have to keep in mind namespaces. Schemas. We need to think of Oracle's ability to perform name resolution. If we just specified orders.orderTotal, well, what if there were 5 orders tables in the database? Oracle would return an ORA error. It would simply be confused. It doesn't like ambiguity. So we're taking the value of that column and packing it into our account balance variable from the orders table, as you already know, where the customer ID is equal to the account number input argument up here. We're returning account balance. Simple as that. So let's select these rows, run the function, and it tells us that the function getBal is compiled. Good. So notice that it didn't actually do anything. The anonymous block that we used earlier just went ahead and ran. Here, Oracle is simply compiling the function, storing it permanently in the database, and as long as a user has the ability to execute this code, that's fine. Now let's actually use the function next. I'm going to just use the dual table in this example. We're going to select getBal, passing in the account number, or the customer ID, I should say, is what it is. The customer ID of 170. We're aliasing that pseudo column as balance from dual. Let's see what comes back. We should see the order total for that individual. And there we have it. In the name of gathering metadata about your objects, or for that matter, other users' objects, I am logged in as sys, the super user, so I can look at every single object, both in all user schemas as well as the data dictionary. There are many different approaches to that. I created the getBal function as sys, so I can query user underscore objects if I want to. Let's look at this query. Select object name, object type, status from user objects, where the object type equals function and the object name is getBal. This is essentially just going to verify that the function does indeed exist in the database, and it also shows its status is valid. In the course I developed for CBT Nuggets for the DBA1 exam, we cover performance tuning and troubleshooting Oracle, how to recompile functions and procedures that go into a corrupted or invalid state. So check out that training if you're interested. As long as we haven't obfuscated, remember that word from earlier in this nugget, our PLSQL code, we can query the data dictionary view user underscore source to take a look at the source code of our own compiled objects. Now, you should recognize everything that's going on in this query starting on line 36. First of all, we'll remember the column command that we can use to do formatting for columns. Here we're saying, take the column text and format it 70 characters across for easier reading. In line 37, we're using tochar, which we'll recall is a conversion function. Tochar can take numeric data or date data and convert it into a string. And here basically line, comma 99, and then concatenating a greater than character is simply going to echo line numbers 1, 2, 3, 4, 5, etc. Comma space, and then text is the text column from user source where name equals getBal. Again, user source, maybe this would make a little bit more sense if I ran a describe on the user source view. There's not too much in user source really, there's just name, type, line, and text. And text is the guts of what we're looking at, the source code. And again, this tochar business is simply going to give us a little bit of formatting to make the source code a little bit easier to read line by line. So let me raise this up, and you can see our lines being echoed, and then here's the source code, which we can select. We can export, we can save, we can do whatever we want to. Yet another reason why it's really convenient to use SQL Developer. Our final example in this demonstration, we'll look at triggers. You see on line 48, I'm taking create or replace trigger and creating a trigger called drop trigger. This is coming to us courtesy of the Oracle 11g documentation. And what this trigger is going to do, it's going to be scoped to the schema level. That is to say, it's going to affect all objects in this example, the HR schema, and it's going to prevent folks from dropping objects in that schema. This is a good real-world example of something you may want to do on high-priority tables in your database. Now then, the trigger syntax is after the create statement and we name the trigger, we specify the scoping. In other words, actually it's the activation and the scoping of the trigger. In this example, I'm specifying before, so that whenever somebody issues a drop on the HR schema, no matter what object it is, this trigger is going to activate before the drop happens. So we're going to prevent it. We're going to capture that DDL statement, nip it in the bud. Our PLSQL block proper begins with the begin, and in this simple example we're going to raise an application error of the ID 20,000 and we're going to echo cannot drop object back to the user. Let's select this, trigger, drop trigger compiled. Good. So now if we come over to an HR session, I'm logged in here as you see as HR. Let me just remind myself of the table names that are in my schema. Now let's try to drop one of those tables. We'll use drop table hr.jobs. And there's our Aura error 20,000 cannot drop object. So we're being prohibited from a drop that as the schema owner, we would absolutely have privilege to do otherwise. So the trigger's functioning as expected. Good deal. PLSQL Basics Review. At this point, you should be able to intelligently discuss PLSQL with other Oracle database administrators and database developers. You understand the basic terminology behind SQL as well as how it's used in business. We also know the fundamentals of the two block types. That is to say, anonymous blocks that are unnamed and not stored in the data dictionary, and named blocks, aka stored procedures or stored routines, and we even know how to create some basic PLSQL examples. You've come a long way if you understand what we've been talking about, and I want to congratulate you for that. I hope that this has been informative for you, and I'd like to thank you for viewing.